Hello, welcome back to another video. Today we'll be covering diodes. The diode is a two-terminal device. It acts as a one-way street which allows current to flow in only one direction but not the other when a voltage is applied. This is the symbol for a diode. You've probably seen this a lot in your electronic circuits, diagrams, whatever not. I've seen this in school. Very popular symbol. Please do remember it. The diode is composed of an anode and a cathode. So on the left symbol side of the diode, we have the anode. So this side is the anode, and this side is what we call the cathode. This is the negative polarity, this is the positive. So the diode is a cylindrical object. And here is a picture of one. I'll put it up on screen now. That's a picture of a diode. And when we forward bias diode, when we apply a voltage across a diode, given we have connected our diode within the proper polarity, so if we connect this properly in our circuit, current will flow across. And remember, I said it only flows across one direction. I think it goes one direction. So if I connect a positive terminal here, negative terminal here, current will only flow in this direction. It will not flow in the reverse. However, this will only happen when the diode's forward voltage is reached, and this can be found in the datasheet of the diode. Now, reverse bias of it does that. So that's the forward bias. So this is calling spell. Let me just get that. So it's forward bias, current flows. Now reverse bias is when a reverse voltage is applied to the diode. So if we connected it in the cathode as opposed to the anode. And from what we've said before, current will not be allowed to flow. So in reverse bias, no current flow. But this will, however, if we were to pass a certain limit, the diode will break down and reverse current will start flowing from the cathode to anode. So if we did apply enough voltage here, it will break down and we can actually make current go in this direction. So do keep that in mind, but usually no current will flow. So here I will show you a working circuit with the diode. So as you can see, I've did a little circuit here. I'm using a tool called Multisim, really helpful piece of software. You could just simulate circuits online. It's just a circuit simulator, and I highly suggest downloading this. You can also see too what's happening. As you know, I'm a true believer that it's not just the theoretical side you need to know to get good. I myself, I'm not, an excellent, the best at electronics. I still have a lot to learn, but from going from university to being an electronic engineer, there's some things at university, especially with COVID now, that, well, when I graduated during COVID, we spent a lot of time online, and it's all theoretical and things. We didn't get a chance to have a go at the lab and everything. So I got into my job and everything. I had a bit more practical hands-on, and that's definitely increased my understanding of electronics and a much easier approach, just from building circuits to playing around with the simulator, applying what you've learned with the theory. And I've learned much more doing that. So really do highly recommend. It doesn't need to be multi-set. There's tons of other like LT Spice, other things like that. So I do highly recommend just have a download, have a go, see what circuits you can build. But anyway, so you can see here our LED has lit up. I've got the diode here. The current is flowing through here quite nicely. nicely. You can even place a current node like that. So we're getting 3.62 milliamps flowing through here, and I will now show you. I'll now show you with the diode in reverse bias. So as you can see here, I've put the diode into reverse bias, and as you can see, the LED is not on anymore. This is because, as I said before, the diode only flows one direction, and if I put a current probe there, and there's basically no current, so it's just picoamps. We basically can say there's zero current flowing because the diode's doing its job. It's doing its job perfectly. It's blocking current. So back to the electronic whiteboard notepad. When it comes to understanding the rating of your diode, first we should know that all diodes, they, like as I mentioned before in one of the first two videos, all electronic components do have ratings, and you do need to look into these because they could potentially damage your components, exceed them, damage your circuit even. So when you come to saying your diodes, each diode will have a thing called PIV. What is PIV? It is peak. Oh, I can just like that. Peak inverse voltage rating. So peak inverse voltage. So you need to look at this and the current. So and the current. You need to keep in mind that of course there's a whole lot of different characteristics to the diode, and you know what you're looking for, especially in your circuits, because you go down the line. But basically, this peak inverse voltage rating is telling you what is the max reverse voltage the diode can handle before it will break down. So remember, I said in reverse bias, if the voltage exceeds a certain limit, current will start to flow. So I'm sure if we applied in a circuit before, I'm sure if we applied enough voltage, there will be an influx of current or voltage that will break that diode down, and that diode will conduct. And the current rating will tell you how much current your diode can withstand. So if a diode has a current rating of 2 amps, do not apply more than 2 amps. So now that you know that diodes block current in certain direction, you might be asking, well, what other uses for diodes? Well, diodes are really useful, and in fact, they're very commonly used components. So I think these diodes can be used to convert AC to DC by making a bridge rectifier. So during the positive cycle of our AC signal, remember that AC is alternating. D2 and D3 are forward bias. So D2, D3 are forward bias. During the negative swing of this signal, the reverse happens. D2 and D3 are reverse bias, so these become reverse bias, and then these become forward bias. And now at the output, what will happen is that from this AC signal coming in here, we get this just from this circuit alone. So now that we see how this works, that these four diodes, the two of them at a time change between reverse bias and forward bias to get this signal. We have a DC signal, but not a very nice one like that. As you can see, there's still gaps in between here that we want to straighten out. Remember I did it from our previous videos. Ideally for a DC signal, we want something just like that, just a straight line. Now there's a component which helps us to achieve that, and I spoke about it quite recently, and that is the capacitor. So by placing the capacitor in parallel, if we place it here, we can help to achieve from, if I just erase these lines here, so we can help to achieve something like, it will look at something like that. It's a much better signal, and And you know, we don't need to put one, we could put more in parallel when needed too. And eventually, you know, even some proper filtering techniques. Okay, from that, and we can get totally to that. If you see this on the oscilloscope, and then we can eventually just get a straight line or clean DC signals. Not only does it help to achieve a more smooth signal that capacitor does, it also filters out any noise. So it's a really good component. So that is all that I have for you on diodes. Thank you for watching and hope you've learned something.